So what we're going to be doing today is we're going to continue talking about constructive and destructive forces. So in the past, we have talked about rivers and streams. All right, so that was last week. And this week, we're going to focus on shorelines and also wind. Make sure as we're going through this ed puzzle that you are taking notes in your interactive notebook, because you can use those notes to help you with future assignments, and also maybe possibly on the assessment over constructive and destructive forces. So let's go ahead and get started. So a shoreline, what is it? It's where land and water meet. All right, we're all pretty familiar with shorelines. They're usually made of sand, and they are created due to the motion of waves. Now, at shorelines, there's erosion. So this is where the waves are removing sand from the shoreline. Because remember, when we're talking about erosion, we're talking about weathered material being transported. And then during deposition at shorelines, you have waves adding sand to the shoreline. All right, so waves are pulling sand away and then also depositing sand along that shoreline. Now, there's a bunch of energy in waves. So crashing waves can break rock and move it back to the shore. Breaking waves can also enter into cracks and break off large boulders. And then there's also the process of abrasion, which is when you have erosion that gets picked up. Okay, so these sand particles in the waves, and those sand particles crash into the rock and cause further erosion. So it's almost like sandblasting. So the sand in the water is being thrown up against the shoreline, and that just increases the amount of erosion. Now, when we're looking at different features, there's a few different features we'll focus on. First one is sea cliffs. All right, so this example of the sea cliff is right here. This is when waves erode rock to form a steep slope. Waves strike the bottom of the cliffs and wear away the soil and rock to make it steeper. We also have sea caves, which is from when waves cut holes into weak rock at the bottom of sea cliffs. All right, so here's an example of a sea cave. This rock right here might have been a little bit weaker than the surrounding rock. That's why when it was waves crashing into it, it was taking away more of the rock in that location than anywhere else. You also have sea arches, where this is where waves cut through a part of a body of rock. Once again, this area here of this body of rock was probably much weaker than the surrounding areas, and it caused erosion, which eventually formed an arch here. And then you have sea stacks. These are columns of rock that are separated from the shore, and they are hard rock that erodes more slowly. So if you take a look over here at this sea arch, maybe this rock over more time will continue to weather and erode, and then eventually you'll be left with something like the sea stack here on the right. Okay, so this harder rock is here making up the sea stack. The surrounding rock was much weaker, and that's how those are formed. Now, before we start talking about depositional features, it is important that we are able to identify these different features. So the sea cliffs, the sea caves, the sea arches, and the sea stacks. That will be on your assessment. Okay, so wave deposition. So features that are formed are beaches. So this is any area of shoreline that is made of a material deposited by waves. So we talked about there's erosion at shorelines, but there's also deposition. So sand is being brought to the coast to create these shorelines that have very fine materials such as sand. So size and shape of beach material depends on how the material eroded and how far the material traveled before being deposited. So if you have like stormy areas, they're more likely to have large rocks, and then other areas are more likely to have smaller particles. That is your typical beach that you would see. Now, there's one thing that we like to talk about here, and this is longshore drift currents. And this forms when waves hit the shoreline at an angle, and sediment is slowly moved in the direction parallel to the shoreline. So what's happening here is this is an example of longshore drift. The waves are coming in at an angle, and what's happening is you've got deposition and erosion, deposition and erosion, deposition and erosion. And what's happening is that sand is moving down the beach parallel to the shoreline. Now, there are features that can be formed due to long shore drift currents, and these are a sandbar, a barrier spit, and a barrier island. So a sandbar is a ridge of material found in the open, a ridge of material found in the open water. If you've ever been to the beach and you wander out, the deeper and deeper you get, and then maybe you come to an area that's more shallow. All that is sediment has been deposited on this ridge, and um, it doesn't. You can't see it from the beach, but as you walk out deeper into the ocean, you may come across one, and then you'll find that there's a significant difference in the depth of the water because you're on that ridge. There's barrier spits, which is a sandbar above water that connects to the shoreline. And there's an example down here. Notice it connects to the shoreline. And then you have a barrier island, which is a long, narrow island that forms parallel to the shoreline. So here's your shoreline up here. And then here's your example of a barrier island. And this is essentially a sandbar that has continued to grow due to sediment depositing, and now you can see that it's above the water. All right, so that was shoreline. So now we're going to talk about wind. All right, wind erosion. Wind moves soil, sand, and small pieces of rock, just like rivers and streams, just like the shoreline, waves at the shoreline. So areas where there's few plants, such as deserts and coastlines, you're more likely to have wind erosion. All right, so you don't have that, for instance, like grass. All right, grass has roots, and what that does is it, first off, covers up all of the sand and soil, but also the roots hold that sand and soil in place. All right, so areas where there's few plants is where you're going to see more of that erosion. There are 3 types of wind erosion. All right, saltation, deflation, and abrasion. So saltation is when sand-sized particles skip and bounce in the direction of the wind. As they're skipping and bouncing, they're also going to cause erosion, with the other materials that the sand-sized particles come in contact with. Then you have deflation, so the top layers of small, fine sediment or soil is blown away, and it leaves larger rock pieces behind. And then you have abrasion, which is sand wears down large pieces of rock, and it's almost like sandblasting. Okay. All right, so here's an example of each of these. So you've got your saltation, wind suspending this. All right, these smaller pebbles are also moving, and then you've got larger pebbles, which kind of move slowly across the surface. Deflation, all right, you can see these larger rocks are exposed because the smaller sediments that covered them have now been eroded and transported somewhere else. And then here's abrasion, where you have these small sized particles being picked up in the wind, and they're basically essentially sandblasting and hitting into this larger rock, which is causing erosion. Now there's also deposition. All right, so once you have that wind pick up the weathered material and transport it, it's got to end up somewhere. So wind can carry sediment over long distances, and there are 2 types of wind deposition. We've got loess and dunes. Now we're probably more familiar with dunes, and we'll get to that in a second, but loess is thick deposits of very fine grained sediment. It almost feels like baby powder, and it can be found far away from the source. All right, so an example of that would be right in here. And it's kind of hard to see in this picture, but at the base of this feature here, you've got a lot of really fine sediment that was just deposited there that came from somewhere else. And then our dunes, this is probably a very familiar image to you. Dunes are a mound of wind-deposited sand. All right, and they move in the direction of the wind. So the wind blows the sediment up the steep side, and then, so what we call the steep side is what we call the windward slope, and then the sediment slides down the other side, which is what we call the slip face. So right here is the windward slope. So wind is blowing the sand, and it's slowly, kind of creeping and moving up. And then once it reaches the top of this ridge, it then begins to slide down. And over time, these dunes, they actually move. So they can slowly move from one location to the next as it continues to creep up and slip down. This very top of the ridge would eventually be over here, and then continue to move and move and move over time. All right, so we've talked about shorelines and wave erosion and deposition, and we've talked about wind and how it can erode and deposit sediment as well. Over the next week or so, we're going to focus on those, and then we will talk about ice and glaciers, and then also how gravity plays a role in constructive and destructive forces. All right, thank you very much. Bye bye.